let's talk about batting performance as our next example. So let's see here. We would like to determine whether there are real differences between the batting performance of baseball players according to their position. So outfielder versus infielder versus designated hitter and catcher. We will use a data set called BAT10, which includes batting records of all 327 Major League Baseball players from the 2010 season with more than 200 at-bats. 6 of the 327 cases represented in BAT10 are shown below. Okay, so we're going to be using the position column and the OBP column. So the OBP is known as the on-base percentage, which is roughly equal to the fraction of times a player gets on base or hits a home run. And here are the descriptions of each of those abbreviations one more time. So again, we're looking at the position versus the on-base percentage. The measure we will use for the player batting performance, the outcome variable, is on-base percentage, or OBP. The on-base percentage roughly represents the fraction of the time a player successfully gets on base or hits a home run. So we mentioned that before. Here's example 5. What hypotheses should be used to test whether there is no difference in the batting averages between outfielders, infielders, designated hitters, and catchers? So the null hypothesis would be that the mean of the outfielders equals the mean of the infielders equals the mean of the designated hitters equals the mean of the catchers. And then the alternative hypothesis would say that at least one position is different from the others. I'll put at least one position's mean is different. Example 6. The player positions have been divided into 4 groups: outfielders, infielders, designated hitters, and catchers. What would be an appropriate point estimate of the on-base percentage by outfielders? Okay, well, if we look at this table, we can see that 0.334 is the sample mean. So this is X bar of the outfielders. And so we would use this as our point estimate. For the outfielders. Below are the side-by-side box plots of the on-base percentage for 327 players across 4 groups. There is one prominent outlier visible in the infield group, but with 154 observations in the infield group, this outlier is not a concern. So if you really wanted to know who that was Brandon Wood, and he played for the LA Angels, I guess. I do not know much about baseball. But I did want to remind us that, remember that the larger the sample, the less the outliers affect the analysis. So 154 observations for the infield group is considered a large sample because it's greater than 100. Okay, so notice that the variability appears to be approximately constant across the groups. So if I kind of highlight the width of the boxes and the medians, so width and medians, width, median, width, and median, they're kind of all clustered around a similar line, horizontal line. So nearly constant variance across groups is an important assumption that must be satisfied before we can test for equal means. Okay, so especially if you look at the designated hitter versus the catcher, and then versus everybody else, but designated hitter versus catcher, you can see that between these two sample means, we see the biggest difference. So we'll just make a note of that. And we can see that up here in the box plot as well. Example 7. The largest difference between the sample means is between the designated hitter and the catcher positions. Consider again the original hypotheses. So the null hypothesis says that all of the means are equal, and the alternative hypothesis says that the average on-base percentage varies across some or all groups. In other words, at least one mean is different than the others. Why might it be appropriate to run the test? Why might it be inappropriate to run the test by simply estimating whether the difference of the mean for the designated hitter and the mean for the catcher is statistically significant at a 0.05 significance level? In other words, why should I still include the data for the other two positions if I know the biggest differences between designated hitters and catchers? Why should I still include the means of the other two positions as part of my analysis? That's the question. So the primary issue here is that we are inspecting the data before picking the groups that will be compared. This is called data snooping. It is inappropriate to examine all data by eye, which is informal testing, and only afterwards decide which parts to formally test. Instead, we should first reject the hypothesis that all the means are equal, and only after that find out which groups are different. Naturally, we would pick the groups with the large differences for the formal test, leading to an inflation in the type 1 or false positive error rate. Remember that the type 1 error it will say that the null hypothesis, it's when the null hypothesis is actually true, but we reject it. So that's a type 1 error, when the null hypothesis is actually true, but we end up rejecting it. So to understand this better, let's consider a slightly different problem. Suppose we are to measure the aptitude for students in 20 classes in a large elementary school at the beginning of the year. In this school, all students are randomly assigned to classrooms, so any differences we observe between the classes at the start of the year are completely due to chance. However, with so many groups, we will probably observe a few groups that look rather different from each other. If we select only these classes that look so different, we will probably make the wrong conclusion that the assignment wasn't random.